Okay, we're going to go ahead and take a look at divisibility rules. Now, most of you know the divisibility rules of some of the basic problems or numbers, like divisibility of 2, divisibility of 3. You might know divisibility of 4. Most people know the divisibility of 10 and of 5. And sometimes people also know the divisibility of 6 and 8 and so on. Now, in this video, we're not going to really go ahead and prove the divisibility of 6. For the most part, when it's like 6, you just need to show that it's divisible by the 2 and the 3 that are the factors of 6. Or like divisibility for 15, you'd have to show that it was divisibility worked for 3 and divisibility worked for 5 because 15 is 3 times 5. Now, this video is going to show you some of the proofs of some of these. So, we're going to look at divisibility by 3. We're going to start off with a 4-digit number. So A's in the thousandths place, B's in the hundreds place, C's in the tenths place, and D's in the ones place. We could actually expand that out, and so we get whatever number's in the thousandths place, it's really 1,000 times that. Whatever's number's in the hundreds place, it's really 100 times that. So we have the expanded form. Now I want to go ahead and just use color, because that's going to help us as we expand this a little bit. Now we're trying to show that it's divisible by 3. So I want to go ahead and write some stuff here that's divisible by 3. I know 999 is divisible by 3 because when I divide it, I get a nice, neat number. I also know 99 is divisible by 3 because that's a nice, neat number. Now, you might be thinking, well, we had 1000A here, now I have 99A here, or 999A. That's true, but 999A here plus this other one red A here is a total of that 1000A. Similarly, this blue 100B is made up of the 99B and of the 1B that's over here. My 10C is the 9C here plus that 1C here. And then I still have my D hanging out at the end. So for the next part, I'm going to go ahead and factor a 3 out of this first part. That leaves these last 4 things at the end. So what we have here is we have the first part being a multiple of 3. If the first part's a multiple of 3, it's divisible by 3. So the whole number n that we started out with is divisible by 3 if and only if these last 3, or last part here, is divisible by 3. In other words, if you take the sum of your digits, because it's A, B, C, and D, because our number was A, B, C, D, if you just add up those digits, if that's divisible by 3, then the original number is divisible by 3. And so this is the proof for divisibility by 3. Now, if we wanted to look at divisibility by 9, we can start out in a very similar way as we did in the last one, because in the last one we had this showing up at one point. You notice 9 goes into all these 3 here to begin with. So we could go ahead and pull a 9 out. On the last one, we pulled a 3 out because we were looking for divisibility by 3. So with that in mind, we have divisibility by 9 here for the first part because it's a multiple of 9. So the whole original number is divisible by 9 if and only if the last part's divisible by 9. So if you just add these numbers up, if that's divisible by 9, the whole original number is divisible by 9. If we look at divisibility by 2, I'm still going to start out by using the expanded form. Once again, still using color. Now, you could look at 1,000 as being 2 times 500, and this being 2 times 50, and 2 times 5, and so on. But what I'm going to do here is going to help me with some other things in the future here. Now, 1,000 is 10 cubed, but 10 cubed is a 2 cubed and a 5 cubed. 100 is 10 squared, and 10 squared's a 2 squared and a 5 squared. 10 is my 2 times 5. So I'm going to go ahead and pull a 2 out because I'm trying to show divisibility by 2. So my original number is going to be divisible by 2 if and only if the last one is divisible by 2, meaning the last digit would have to be an even number. Because this first part, I pulled a 2 out, and that's a multiple of 2, so therefore it's divisible by 2. So the whole number is divisible by 2 only if the last number is divisible by 2. Now that one's not too hard for most people, but I started out this way because that's going to help us when we move on to 4. When we move on to 4, we're still going to start out with our expanded form. Still going to start out with the 10 cubed and the 10 squared. Still go to the 2 cubed and the 5 cubed, the 2 squared and the 5 squared for my v here stuff. Now, looking at divisibility by 4, I want to go ahead and in this line, now I want to pull out a 2 squared, which 2 squared is really a multiple of 4. So I'm really just pulling a 4 out of here. Now, I didn't try dealing with the 10 here because I know 4 doesn't go into 10. So I just dealt with the part that I could take a 4 out of. Now, with that in mind, I can actually go ahead and say, well, the first part's a multiple of 4, so therefore it's divisible by 4. So my whole number is divisible by 4 if and only if this last part's divisible by 4. So in other words, if the tens and the ones digit is divisible by 4, if that two-digit number is divisible by 4, then the whole number is divisible by 4. Divisibility by 5, we're still going to start out with that expanded form that we were starting out with on most of these problems so far. Now, we're going to go ahead and try to pull a 5 out of as many things as we can. Now, we can pull the 5 out of the colored part here because 5 is a factor of all of these. It's not a factor of the last one. So then we end up getting the same situation we had before, where the first part's a multiple of 5, and so therefore it's divisible by 5. So the whole thing is divisible by 5 if and only if the last number is divisible by 5. And we know the only numbers that work for that last number for it to be divisible by 5 are 0 and 5. And that's what our divisibility rule says. So what about something like 7? Now, the divisibility rule for 7 is not one that's commonly known, but we can still go ahead and prove it and derive it here by using the same technique. Now, on these last problems, we tried to get, if for divisibility by 5, tried to get something that was a multiple of 5, or divisibility by 9, something that was a multiple of 9. So we're going to use that same technique here. So I'm still going to start out with my expanded form. Now, I'm going to go with 700a because I know 700 is a multiple of 7. You notice I have a 700a here, plus this 300a over here is my original 1000a. Also, I'm going with a 70b because I know 70b is a multiple of 7. But my 70b here plus my 30b that's over here is my original 100b I had here. Looking at the green, instead of 10c, I'm going with a 7c because that's multiple of 7, and I'm going with a 3c because 3c and 7c is at 10c. And then I'm going to go with a 7d. Now, 7d, and if I subtract 60, gives me that 1d. Now, I can see out of that first part, I can pull out a 7. And if I can pull out of this 7, I know that for this first part, it's going to be divisible by 7. Second part here, I happen to pull out a 3. Now, what happens here is if the first part's divisible by 7, because it's a multiple of 7, the last part is really what determines if it's divisible by 7. So, as we look here, we have divisibility by 7 for the first part. So all we can say is then that the whole original number of a, b, c, d is divisible by 7 if and only if we double the last digit, because that's what we're doing here, doubling the units digit, and subtracting that from the rest of the digits. Now, we might have to repeat that at times. So let's take a look at an example here. So here's our original number. We want to know if it's divisible by 7. So our rule was we need to double the last digit and subtract it from the first ones. So I'll double the units digit, subtract that from the original ones, and I get this here. Now, all I have to do is just repeat that process. I need to double my units digit and subtract it from these red ones. And so that's what we're doing here, taking the red ones, doubling the units digit, and I get this. This is still not a number I know off the top of my head to know if 7 goes into it, so I'm going to repeat the process. I'm going to take the double the units digit and subtract it from the red ones. And I get 84. Now 84, some of you might know if that's a multiple of 7. Some of you may not. So we could repeat the process. So we take our 8 and subtract 2 times the units and we get 0. Now 0 is divisible by 7. So therefore our original number is divisible by 7. If we got something here that was not divisible by 7, the original number would not be divisible by 7. Now, if you are interested in divisibility by 11 and 13 and how that stuff works, that'll be in the next video.